6.7 Cummins diesel roller cams. Let's talk about them. All right, so I had put we had I've been trying to get a hold of 6.7 roller cam, and I couldn't find one that was a decent price. I mean, a good used one. I mean, they trying to get $300-400 for a good used one. So luckily we had. I assume he watches the YouTube channel too, but I posted it on the Facebook page. Hey, I'm looking for one, and a guy in California is like, man, I got a cam and lifters. Apparently, he worked at a dealership. He's like, I got a good takeout cam and lifters. You can have them. So he packed them up. I sent him a shipping label, and he was nice enough to pack it all up and ship it to me. I got it. The cam is in great condition. We washed it up, even still had the gear on. So we pressed the gear off, and I run it in the cam doctor because the plan, the point of the whole deal is I wanted to see what the factory specs were because we're planning on manufacturing some of these roller cams because they're just dying left and right. But I'm finding out that lifters are the problem. There's just no aftermarket source for a factory roller lifter for a Cummins. They just don't exist. I don't know what they cost from Cummins, but apparently and I can see it. So apparently the wheel and the axle is the problem in the lifter. And every one of them, I got a whole box full of them, and the axle is actually loose. They may come that way. I don't know, but generally the axle is staked in place and the axle doesn't roll, and the axle is loose in every single one of them. I mean, it's actually got in play. You can push it back and forth. So I was going to push the axle out and, just see what the system looks like. Does it got bearings in it? Is it just, metal on metal? I mean, some of the Caterpillar stuff, the big diesel cats, I mean, they got an axle and wheel. There's no bearings. It's just a wheel riding on the axle. So I don't know if it's like that. I mean, I have no idea, but nothing is hurt. All the lifters look good. All the lobes look good. But what started this video is when I run, and we'll get to all that. We got graphs and cam doctor reports and all of that. But what prompted this video is I run it, and I looked at the Lobe designs, and I'm like, dang, that's a solid roller design, and it's got a hydraulic lifter on it. And I made a post, and I'll put the post up here, but I made a post, just kind of in jest that the Cummins engineers must have forgot that the 6.7 had a hydraulic lifter because the Lobe design is a constant velocity solid ramp, which is really weird that you would put a hydraulic lifter on that. And it's even more weird because they're probably giving up a good bit of torque using that because how slow the valve opens. Because down there in the lash ramp area, it is ultra slow because a regular solid lifter, it wouldn't even make contact till way up here, and the hydraulic is making contact the whole time. So it's just slowly, it's super slow, it's opening. So the valve is cracked off the seat for, 15 or 20 degrees before anything really starts happening, which is really weird to me. But, so several people on the post was like, man, you need to do a video to talk about this and why, where, when, and how. And so for giggles, and they may not be worth a crap. It may just, crap the bed. But I whittled up some Lobe designs that I think would be more appropriate for this scenario. And we took the originals and what I designed, put them side by side on the screen so you can see the difference. And with the constant velocity ramp, or the constant velocity area, you can really, because we did the other video, and I'll link it, the video about, what does all the squiggly lines in this graph mean, right? And we talked about all the derivatives, acceleration and velocity and jerk and all of that stuff. And so this factory lobe design with constant acceleration area is a perfect example of what's happening to the acceleration curve and how all of that stuff works together. And I think visually it's really, really good to help most people visualize what's going on. And then I'll explain it like a hillbilly, and it'll make more sense. So let's get the graph up, and I'm going to start the screen recorder right now. Here we go. All right. So the right lobe, so this lobe over here is on the right side is mine. The lobe on the left is the factory lobe. So let's just start with theirs on the opening side. So all the way to the left on their lobe is the opening side. And I'll put arrows to all this stuff. So if you can see, so the green curve is the velocity curve. So velocity is the rate of change of lift. So think about, if you see it come, so that, obviously this straight line would be the base circle. So it comes up at an angle, right? So it's increasing and then it levels off. So what happens is as it starts coming up, you see the acceleration go up, because acceleration is the rate of change of velocity. So you see the acceleration come up, and then as the velocity plateaus and it's just up, and so think about just going down the road in your car at 45 miles an hour. So you accelerated up to 45 miles an hour, and now you're maintaining 45 miles an hour. So that's exactly what's happening right here. But notice the acceleration curve dips back down to zero because there is no rate of change. It come up to 45 miles an hour and it's maintaining 45 miles an hour for this span of time. And then it starts increasing. And then you see the acceleration come up, and then it plateaus again, because the rate of change up here at the top, the rate of change has stopped increasing again. It's maintaining this much rate of change. And then the rate of change, it actually slows down, and then you see the acceleration come down into negative acceleration. And so, but the way the acceleration curve does, especially right here with this constant velocity area, I just felt like was a really, really good, real world example of what's happening in the system, right? What the lifter sees. And so if you come down here to the actual lift curve, you can see how long this tail is down here. So, you just think about the with a hydraulic unit, right? So it's going to start moving the valve immediately when, it sees lift. So it stays in this really, really low lift area for a pretty good while, and then it starts up the line. Conversely, if you look over here at mine, you see it's a much, faster moves it on up. You just ain't out there in limbo for so long. So then if we come up here and look at, again, this may not work at all. This just may be garbage, but I feel like this will work better. But if you look at ours, you don't have a constant anything, right? It just comes off of the base circle, nice and smooth, and just rolls right up into peak acceleration. And ultimately, the intake, the acceleration numbers and the velocity numbers are pretty well the same. We just achieve it in a different way. That I feel like it is better. And I still kept it slower than I think it can go faster than that. And when I'm talking about faster, I'm talking about at the pickup point. So usually, I don't know what anybody else does, but the way I do it at 4,000ths, so like probably right in here would be like 4,000ths lift. I have a velocity and acceleration number that I want to be here when it comes on to the lobe. And so after that point, then we start increasing, exponentially up to positive acceleration. So, and then on the closing side will be, not a way lot softer, but will be softer on the closing side. So let's swap over to the exhaust lobes. All right, so here's the exhaust lobes. So again, it's the same scenario. We got constant velocity ramps just like the intake. And again, you can see these are longer on the exhaust, so you can really get a feel for how the velocity and acceleration work together. So as velocity is increasing, you'll see an increase in acceleration. And then as velocity plateaus and maintains a speed, then it doesn't matter how high velocity goes. As long as it stops increasing, you'll see acceleration go back to zero, just like you do here. And then, like I say, it's going to go up. And both intake and exhaust, the acceleration were the same. The velocity was actually higher on the exhaust, but the acceleration was essentially the same. But you can see down here how much longer the ramps are. Um, and again, it's crazy to have that much because it's just out there doing nothing for no reason. And then when you put a hydraulic lifter on it, it's just really, I don't know, it's just weird to me. So anyhow, come over to mine, and I still don't have a constant anything, but I do kind of drag the acceleration curve out a little bit. But again, if you look at the actual lift curve, you can see that, it gently comes off the seat, but it just moves right on. You don't get this big long lingering down here at no lift, which again, I just don't see any advantage to this. The lift is so small, there's no flow that amounts to anything. And it just why would you do that? I don't know. But I did slow the acceleration down just a little bit on the exhaust side because generally speaking, we always find that it's just a better deal to have a little less acceleration, just because we're dealing with exhaust gases. It just seems to work better every time we've tried it. So I feel like this is a better deal. Um, overall, the 200 numbers are way better on, and again, mine are bigger, right? I think factory was like 163 and I made a 175, and then the exhaust was a 2. I'll put the cards up here on the screen because I made cards for both cams, and I opened up the lobe separation a little bit because this thing has negative, like the factory cam has like negative 20. Oh Lord, I don't remember, 26 or 7. Again, I'll put the cards up here. 26 or 7 degrees of overlap, and then mine's got like negative 21. Again, negative is, if it was negative 5, it's still negative. The exhaust intake and exhaust are not open at the same time, so you don't really have to worry about cross flow. So, we need somebody like, somebody that knows Gail Banks. They need to get Gail Banks in on this deal, and I'll grind some cams, and Gail can do some testing and see if I'm off in fantasy land or not. But I don't know anybody that's doing any roller cam testing. But I would love to get a couple of grinds nailed down and then start offering these like just factory drop in replacement cams that are better than stock, much better than stock. Because I really feel like that shorter 6 number is just going to make more power, and it's going to be just nicer on the whole thing. I mean, I could be totally wrong, but I feel like that it'll be better, right? But I just don't see, like, the way it's made. I don't think it's ideal, but I still don't think that's what's going on with the murder in the cams. I think that the lifter is garbage, and the way the axle or the way they stake the wheel. But again, I've got one apart. I got the hydraulic unit out of it, and I'm going to press the axle out and inspect all of that system, how that works. But and if viewers know, but I'm not aware, and I've searched all over the internet and I've called multiple part suppliers, I can't find anybody with a replacement lifter, a roller lifter for that deal. I can't. I haven't seen one. So I hear there's some like super expensive aftermarket solid ones, but I didn't actually see those either. And if that is an option, then it would be super simple to just tweak the profile to a solid roller profile and do the exact same thing with a solid roller profile and call it a day if a lifter's available. But I don't know. I don't know if a lifter's available or not. So I got a couple of warehouses looking into it, but I haven't heard any positive back yet. So if anybody knows for sure, it will be nice to have a lifter with a hydraulic unit that we ain't got to deal with lash. And I don't think the hydraulic unit is any part of the problem at all. I'm sure it's all just the wheel and the axle. And I don't think the cam's going to be no problem. As long as we can keep the wheel and the axle happy, and them's keywayed, got a little keyway in them. As long as we can keep the keyway in it, they shouldn't be an issue, with good quality stuff. But I really, really think the axle and the wheel is the culprit in the whole deal. So hopefully all of that was answered all the questions, because like I said, there were several people on the original post that wanted some explanation. Why did I say it was a solid load with a hydraulic lifter? And I hope that unpacks why that, because those constant acceleration, constant velocity ramps, like that was a thing, and it still is a thing for some places, but in the 70s, 80s, 90s, tons of people designed solid roller loads like that. That's just how it was done. I'm not saying there's anything wrong with that. I'm just saying that there's probably a better way to do it today. Even with a solid, we don't do that with a solid. The solid will look visually like a hydraulic, right? We just set the numbers where we want them to when it comes on at the height we want it to be, and it's still just a gradual ramp up to the pickup point. So I don't do all of that, just out there in limbo for whatever many degrees. I don't do it that way. So anyway, not that it's right or wrong. I'm not saying any of that. I'm just saying we don't do that. So, but anyway, y'all get Gail Banks on this deal. I want a phone call from Gail. We're gonna test some cams, and if anybody knows where to get some lifters at, because if we're gonna do, if we're going to do cams, we got to have a lifter source to make it a viable option. So, all right, y'all have a great day. Hopefully that was interesting. Thank you so much. We appreciate all the support. We'll see you on the next one.